Alright, so for our third part of this video, we're going to take a look at the last one. We're going to look at oblique asymptotes. So, first of all, what do we need to have an oblique asymptote? How do we know there's going to be an oblique asymptote? So, what you need is you have to have the degree of the numerator being exactly 1 greater than the degree of the denominator. That will give us an oblique asymptote. Okay, so the degree, I should have written this out ahead of time. The numerator is exactly, now it has to be exactly 1 bigger than the denominator. There we go. Okay. Let's see. So, first of all, you can see, so here's an example. Here we've drawn 2 oblique asymptotes. The green line and the blue line. Obviously, it's not going to show up as green and blue on your sheet, but you can see those are oblique asymptotes. And so if I want to come up with the equation of those, I just look at them and I say, well, the first one, we're just back to grade 9 math. So the first one has a positive slope. It's going up, rise over run of 1. So it's just going to be x. And then we look at the y-intercept is -1. So it's just x minus 1. Okay. And the other one is going down. It still has a slope of 1. So it's -1x. And the y-intercept is 1. So it's plus 1. So there's the equations of our oblique asymptotes. All right. So how do we find the oblique asymptote? So what you're going to do is you're going to rewrite your equation. And what you're going to do is you're going to use your long division algorithm. Unfortunately, synthetic division probably won't. It will work some of the times, but most of the time it won't work. So you're going to have to use your long division algorithm that you learned last semester in advanced functions. And so you're going to rewrite f of x. So you can see we've got f of x is equal to p of x over q of x. Okay, so it's just a polynomial over a polynomial. And what you're going to do is you're going to rewrite it. Once you divide it, all right, once you divide it, you will write out sort of your answer. So what your answer will be is just, it'll be some sort of mx plus b, okay, whatever that is, okay? And then you'll probably have a remainder. You might not have a remainder, but you'll probably have a remainder. Or if you don't have a remainder, then you're just graphing a line. Your equation's not that fancy. So you should have a remainder. And what you'll do is you'll just say plus whatever that remainder is, okay, divided by that q of x still, okay? So you're doing q of x, or sorry, p of x divided by q of x, but you're doing it the long way. So what you'll get is this is where you'll have that, this is where you'll have mx plus b is your answer up there, and you'll have your remainder down here. And so you can just rewrite this in this form, okay, and that is the function. And what then your oblique asymptote is, your oblique asymptote is just going to be y equals whatever your mx plus b is. And you can just ignore this part here. And the reason you can ignore that is because as the limit approaches infinity, because this r is just a number, it should be approaching 0, whether the q of x is approaching positive infinity or negative infinity. It doesn't matter. It's that part of it will just approach 0. Okay? So that was a lot shorter than the last 2. I do want you to actually attempt to do example 9 before class so that we can do that together, or at least read through it and try and refresh yourself on your long division. I'm sure you haven't done it since you learned it last time. So, okay. Until next time, go Sabres.